$2. That is what the powder costs that the air conditioning industry has spent decades hoping you never find out about. Not $2 per application, $2 per pound of 4A zeolite powder, available from any industrial chemical supplier or on Amazon, and capable of producing a cooling effect that United States Navy testing described as equivalent to an 8 degrees Celsius sustained temperature reduction, lasting more than 2 hours with zero moving parts, zero electricity, and zero refrigerant. The global air conditioning market was worth $130 billion in 2024 and grows every single year. Each residential split unit installation generates between $1,200 and $3,500 in contractor revenue. Annual maintenance adds another $200 to $400 per unit. The industry does not sell cold air, it sells dependency. A compound that cools without compressors, without refrigerant gas, and without an electricity bill does not fit that model. It has no distribution margin. It cannot be patented in its natural form. And that is exactly why it never appears in any installer catalog. Zeolite is not a recent discovery. It is one of the most ancient and thoroughly studied materials in the entire history of thermal engineering. The first modern scientific record dates to 1756, when Swedish mineralogist Axel Fredrik Cronstedt described the capacity of certain aluminosilicate minerals to absorb and release water reversibly without degrading. Cronstedt called the phenomenon zeolites, from the Greek zein lithos, the stone that boils. What he observed in his laboratory, civilizations separated by thousands of miles had already been applying with empirical precision for centuries. In 4th century BC Persia, engineers built the yakhchal, domed structures constructed with a mortar called saruj, a mixture of sand, clay, lime, and ash with extraordinary insulating properties. These structures connected to qanats, underground water channels that crossed the desert floor. Hot, dry air entered through wind towers called bajir, descended into the underground passages, became saturated with moisture over the cold water, and emerged into building interiors at temperatures up to 15 degrees Celsius below the outside air. There was no motor, there was no gas, only geometry, porous materials, and the principle of adsorptive evaporative cooling that modern engineering programs now teach at the postgraduate level. Ancient Egypt applied the same principle 2,500 years before Christ. Friezes from that period show servants fanning porous clay vessels to cool interior rooms. The walls of the jars allowed water to migrate slowly to the exterior surface and evaporate, absorbing heat from the surrounding air. Passive adsorption at domestic scale. In China, during the Han Dynasty, around 200 BC, builders of imperial grain warehouses incorporated layers of calcined volcanic clay into the walls of food storage facilities. That volcanic clay was, in composition, natural zeolite. The humidity regulation it provided kept stored grain viable for years without spoilage, a problem that warehouses built without the material solved only partially and with constant losses. Administrative texts from the period document the performance difference between the two types of facility with an accounting precision that was, unknowingly, the first comparative zeolite efficiency study in recorded history. In the 19th century, during construction of the United States Transcontinental Telegraph Network, field engineers working through the Nevada and Utah desert documented spontaneous cooling around outcroppings of a pale granular rock they called clinoptilolite. Water condensed on metal equipment near these formations even during peak afternoon heat. Nobody understood the mechanism. The observation was logged, filed, and ignored for 80 years. It was not ignored by the United States military. In 1944, the Office of Scientific Research and Development commissioned a series of field trials evaluating natural mineral compounds for passive climate control in forward operating positions in the Pacific Theater. The objective was to reduce heat casualties among troops stationed in concrete bunkers on captured islands where mechanical cooling was impossible to maintain under combat conditions. Zeolite aggregate packed into wall cavities and moistened twice daily produced consistent interior temperature reductions of 6 to 9 degrees Fahrenheit compared to control structures. The program results were classified as restricted technical information and remained largely outside civilian literature until a partially declassified summary appeared in a 1978 Department of Energy report on passive solar and thermal mass building strategies. The Navy continued internal research. By the early 2000s, the Naval Research Laboratory in Washington was publishing peer-reviewed work on zeolite adsorption cycles for shipboard cooling systems, citing energy reductions of up to 40% compared to conventional vapor compression systems in enclosed compartment tests. The academic literature is not hidden. A 2003 paper in the journal Solar Energy by researchers Restuccia, Freni, Vasta, and Aristov at the Italian National Research Council documented a zeolite water adsorption cooling system achieving a coefficient of performance of 0.58 under conditions replicating residential summer loads in southern Europe. A 2019 review in Applied Thermal Engineering surveyed 41 independent studies on zeolite adsorption cooling across 3 continents and found consistent efficiency results ranging from 20 to 60% energy savings depending on application format. The research exists, the results are replicated, the patents filed around engineered zeolite composite systems are real and valuable. The raw powder itself remains unpatentable, abundant, and $2 a pound. In the description, you will find a complete field manual with the exact protocols that building engineers in Japan have been applying routinely for 2 decades, and that never appear in Western HVAC service documentation. Now, the practical application. You buy zeolite 4A powder or granules, also sold as molecular sieve 4A, from chemical suppliers including Sigma Aldrich Industrial Division, U.S. Chemical Storage, or through Amazon from suppliers like Absorbest or Zeolist. The price runs from $1.80 to $2.50 per pound in 5-pound quantities, and drops below $1.20 per pound at 25 pounds. You do not need laboratory grade. Technical grade works identically for thermal applications. The first method is direct passive panel application. You take a standard window screen frame, available at any hardware store for under $3, staple a layer of burlap or coarse fabric across it, and pack a 1-inch layer of moistened zeolite granules across the fabric surface. You hang the panel in front of an open window or in the path of any fan. As air passes through the granule bed, zeolite adsorbs ambient moisture and releases that energy as a cooling effect on the airstream. A single panel measuring 2 feet by 3 feet, using less than 4 pounds of zeolite, produces a measurable temperature drop of 4 to 7 degrees Fahrenheit in a standard 12 by 14 foot room within 40 minutes. Total material cost, under $10. Equivalent portable evaporative cooler. Retail price, $120 to $400. The second method is wall cavity thermal mass enhancement. In any wall cavity accessible during renovation, whether in a new build or a gut renovation scenario, dry zeolite granules poured into stud bays before drywall installation create a passive humidity and temperature buffer that reduces peak interior temperature swings by up to 30%, according to field measurements published by the Oak Ridge National Laboratory Building Envelope Research Program in 2011. Material costs for a standard bedroom wall, $14 to $20. The effect lasts the life of the structure without replacement or maintenance. The third method applies to attic spaces, which account for 30 to 40% of summer heat gain in residential construction. Spreading a 2-inch layer of dry zeolite granules across attic floor insulation on top of existing bats or blown-in material adds a hygroscopic thermal mass layer that absorbs daytime heat and releases it slowly through ventilation during cooler nighttime hours, reducing attic peak temperatures by 12 to 18 degrees Fahrenheit in documented field trials. Coverage for a standard 1,200 square foot attic requires approximately 300 pounds of granules at a total cost of under $400. A professionally installed radiant barrier for the same space runs $1,500 to $3,000 and performs less effectively under high humidity summer conditions. The fourth method is the most immediate. You take 2 pounds of zeolite granules, spread them in a single layer across a shallow baking tray, pour 1 cup of cold water over them evenly, and place the tray directly in front of any box fan or tower fan. Within 15 minutes, the room temperature begins to drop. This is not evaporative cooling in the conventional sense. The granules absorb the water into their microporous structure, and the thermodynamic energy released by that absorption process goes into cooling the airstream passing over the bed, rather than into evaporating water into the room. The result is cooler air with lower, not higher relative humidity. This is the key distinction that separates zeolite cooling from conventional swamp coolers, which fail in humid climates. Zeolite works in Florida in August. Total cost of this method? $4 in materials plus whatever electricity your fan already uses. Regeneration is simple. When the granules are fully saturated, you spread them on a tray and place them in an oven at 300 degrees Fahrenheit for 2 hours. They return to full adsorptive capacity, and the cycle repeats indefinitely. The same 2 pounds of zeolite you buy today will still be performing identically in 20 years. The Persians built their wind towers and connected them to underground channels because they understood, without instruments or equations, that porous materials and moving air could defeat the desert. The Egyptian servants fanning clay jars understood that a wet wall gives something to the heat, takes it in, holds it away from the living. The Han Dynasty warehouse builders chose their volcanic clay deliberately, generation after generation, because the grain it protected proved it right every season. The Swedish mineralogist who named zeolite in 1756 was simply giving a Latin title to a material that human beings had been trusting with their survival for 3 millennia. The United States Navy confirmed it under combat conditions. 41 peer-reviewed studies confirmed it again. And now a bag of technical-grade molecular sieve sitting in front of your box fan on a July afternoon will confirm it one more time, personally, at a cost of $2, against a $3,000 machine that requires professional installation, annual servicing, and a monthly utility bill to deliver a result this powder has been delivering since before Rome was built. If this changed the way you think about cooling your home, subscribe and share this with one person who is about to spend money they do not need to spend.